Good morning, everybody. This is Danny Mathematics. I'm here with another example to explore. And today, guys, I want to go over example 1 and example 2 of how to solve percent word problems that are dealing with percents, right? And percent word problems, right, they fall under the proportionality umbrella, okay? They fall under the proportionality umbrella, meaning that for us to solve, we can either use the box method where we cross multiply, right? Because everything is proportioned, or we can use scale factoring to solve this particular problem. So I'm actually going to show both ways on these two problems, okay? So the first problem, guys, that I want to go over is example 1, okay? And once again, before I even start reading the word problem, I just want to go over the 3 different parts when it comes to solving percent problems, okay? So for example, guys, we have the box method, okay? This is the method that I use with my students when I solve percent word problems, which is proportionality, right? Or any proportionality. When it comes to unit rates or ratios or measurement conversions, I use the box method, okay? But with percents, here's how it goes. In the top left box, the value that represents the percentage of the subject, whatever the subject is, right? The value of that percent will go in the top left box, right? The quantity of the subject, right? The quantity, the actual quantity of the subject is the part. It will go in the top right box, right? 100 represents total, right? 100 represents total. That's 100%. It will always go in the bottom left box. And whole represents the total amount of whatever we're talking about, okay? The whole will always go in the bottom right box, okay? The bottom right box, okay? So 100 would always be 100. So we have these 3 different parts. We have the percent, the part, and once again, the percent and the part will represent the same thing, okay? So for example, if I'm talking about the student body at my school, right? But the subject is girls, right? Not all girls or not all students are girls at my school. There are also boys. So the total is all students, but the subject will be girls, right? So I can find how many girls is at the school and the percentage based on the total, okay, of how many girls is at the school. So I'm just using that as an example, okay? So for example, guys, we have the percent and we have the part. They represent the same thing, and the whole is just the total amount of whatever we are talking about, okay? So let's go ahead and start this problem. And the last thing I want to say is, guys, the word problem will always give you 2 of these, okay? So for example, within the word problem, they give you the whole and they give you the part, then that means they want us to solve for the percent. If they give us the percent and they give us the part, that means that we're solving for the whole. If they give us the percent and the whole, that means that we're solving for the part. So whatever part that we do not have, that we have to set as X, that's what we're solving for. All right, so let's go ahead and start, guys. Example 1 says CJ is selling Starburst candy at his high school, okay? He's selling Starburst candy at his high school. At the beginning of the day, he started off with 400 pieces of Starburst, okay? By the end of the day, he had only 160 pieces of Starburst left. What percentage represents the number of Starburst CJ sold that day, okay? So as I solve this word problem, guys, I just want to go step by step of what I would show my students and the questions that I would ask my students in order for us to understand what we need to do, okay? So the first piece of information that was given was the whole or the total, right? Another word for whole is total. I'm just going to put that in parentheses so you know what it means, okay? All right, so CJ, he's selling Starburst, and the total number of Starburst that he took to school that day with him was 400 pieces of Starburst. So I'm going to underline that part, and that is the whole, right? So 400 Starburst. That is the whole. That is the total number of Starburst he took to school, right? Now, it says by the end of the day, he had only, I'm going to underline this, he had only 160 pieces left, okay? So that's how many pieces that he had left that he did not sell, right? But the question is asking what percent, right? What percent represents, and I want to underline that. So what percent represents the number of Starburst CJ sold? So this is the percent, or this is the subject of the percent, right? This is what the percent represents. The number of Starburst CJ sold, right? He didn't sell 160 Starbursts. That's what he has left. So for us to find out how many he sold, we got to subtract 160 from 400 to find out the part, okay? So once again, guys, the percent and the part represents how many Starbursts he sold, okay? So let me go ahead and do that. So once again, guys, he started off with 400 Starbursts, which is the total. Oops, total. And I'm going to subtract the number of Starbursts he has left over, and that should give me the number of Starbursts he sold, okay? So 400 minus 160 is 240. So he sold 240 Starbursts, right? Starbursts. I'm gonna put it like this, Starbursts, right? So once again, that is the part. That's how many Starbursts that were sold, okay? That's how many Starbursts that were sold. Once again, the percent has to represent the number of Starbursts that were sold as well, right? So let me write that also. So Starbursts sold. Once again, the part and the percent represent the same thing, right? So they want us to find out the percentage of the Starbursts that were sold, which is 240 Starbursts, right? We don't know the percentage yet, so because of that, I'm gonna put an X, because we do not know the percentage, okay? But we can find out the percentage because we have the total number of Starbursts, we have how many Starbursts that were sold, and based on the number of Starbursts that were sold compared to the total number of Starbursts, we can find out the percentage of the Starbursts that were sold, okay? So here's what we're gonna do, guys. We're gonna plug these particular values within the box method and solve, okay? So here's the box method. Now, once again, guys, there are two different ways to solve. You can either cross multiply or you can do scale factoring. In this first example, I'm gonna do cross multiplying. But the second example, I'm a scale factor, okay? So I can show you both ways. But either way will work, okay? So box method. Once again, draw a box. Divide it into 4 boxes, just like over here. And we literally just following this format, okay? So the top left box is the percentage, right? We don't know the percentage, so we label that as X. So I'm gonna put an X right here representing the percentage, okay? And then once again, guys, the subject line is the Starburst sold. The subject line represents the number of Starbursts sold, right? Or the percentage of Starbursts that were sold. Okay, that is the subject line, which is the first row, okay? So we don't know the percentage of the Starbursts that were sold, but we do know that there were 240 Starbursts in total sold that day, right? 100 is still 100. Okay? And then the whole, which is the total number of Starbursts he started off with, is 400. Okay? So what we're going to do is, guys, we're going to cross multiply. So I'm going to show you the first method, okay? So as we cross multiply, we're going to do the butterfly, okay? Which is cross multiplying or multiplying in a diagonal, okay? So X times 400 or 400 times X equals 400X. Okay, we don't know the value of X, so all we just need to do is just attach X to 400, meaning that we're multiplying them both together. All right, but we don't know the value of X just yet. And on the other side, guys, it's gonna be 100 times 240, right? 100 times 240, so let me go ahead and put that. So 100 times 240. Okay, now, here's a little trick that I show my kids whenever we're multiplying big numbers, and the numbers that we're multiplying have consecutive zeros starting at the ones place, okay? 240 has a 0 in the ones place, and 100 has consecutive zeros, 2 consecutive zeros starting at the ones place. what we can do is we can cross out those zeros and then reattach them after we multiply 24 times 1 or 1 times 24, right? So 24 times 1 is 24. So if that's the case, 100 times 240, all I have to do is just attach those 3 zeros, is actually 24,000, okay? So once again, all I did was multiply 24 times 1, which is 24, then the zeros that I crossed out, I reattached them. So 100 times 240 is 24,000, okay? So I have 24,000 equals 400x, or 400x equals 24,000. Now, in order for us to find out the true value of x, guys, we have to detach x from 400. And the opposite of multiplying is dividing, right? So I'm going to divide both sides by the value that's attached to x, which is 400. Okay? So 400x divided by 400 is just 1x. Okay? And then on this side, guys, I'm going to do the same thing. Now, that same trick that I did with multiplying big numbers that have consecutive zeros starting at the ones place, you can do that same trick while dividing, but the only difference is you don't reattach the zeros because we're dividing, right? So I can cross out a 0 for a 0. There's a 0 in the ones place and there's a 0 in the ones place here, so I can cross this set out. Now I have 2,400 divided by 40, same thing. There's a 0 in the ones place and there's a 0 in the ones place down there, so I can cross those out. Now I have 240 divided by 4. So that's what I'm going to do on the side, guys. I'm going to do 240 divided by 4 and see what I get. Okay. 4 cannot go into 2. It goes in there 0 times, but it can go into 24 6 times. Okay. And then 4 times 6 is 24. And 24 minus 24 is 0. And then all I need to do is just bring up the other 0, right? Just bring this 0 up. So the value of x, guys, is 60%. Meaning that out of all the Starbursts that he brought to school that day, he sold 60% of them. Okay, so this is our final answer, guys. 60% sold. Okay, so the 240 Starbursts sold is 60% of 400, right? 240 is 60% of 400. So either we could say he sold 240 Starbursts, or if they wanted the percentage, we could say that he sold 60% of the Starbursts. Okay? Now let's go over here, guys. I want to do another example real quick. This is example 2. Same format, guys. Once again, you can either cross multiply or you can do scale factoring. On this one, I'm going to try to show both, just both ways on this one, okay? So same format, guys. Once again, they're going to give us information where we're going to have 2 out of the 3 categories that we need. Whatever one we don't have, that's the one that we need to solve for, okay? All right, so on this one, guys, it says Coach Davis decided to donate $800 to a local charity organization. If the $800 donation accounts for 16% of his total savings, then how many was in his overall savings before he donated, right? Or how much, my bad, how much money, and that was a little typo, let me put money, how much money was in his overall savings before he donated, right? So let's look at the question, guys, and that's the main thing that I try to tell all my students. The question is telling you what they want you to solve for, right? So I'm gonna underline it again. How much money was in his overall, keyword is overall, right? Overall savings. Overall means total, right? Or whole, right? So that's letting me know that we do not know his overall savings before he donated to the organization, right? So we don't know the total, right? So I'm going to put an X, right? But we do have the percent and the part, and we do know that the percent and the part represents the money that he donated. So that's going to be the subject line. That represents the money that he donated, okay? Or the percentage of the money that he donated, right? Compared to his overall savings. So out of the money that he donated, right? He donated $800, which is the part. So he donated $800, but the $800 is 16% of his total savings. Okay? So once again, he donated $800, but $800 is 16% of his total savings, okay? And this is what he donated, right? So now, guys, all we need to do is just plug in these values to solve to see how much money did he have in his overall savings, which represents the whole, okay? So what I'm gonna do is, guys, I actually wanna show both ways. I'm gonna do cross multiplication and I'm gonna do scale factoring. Okay, so let's do the cross multiplication way. I'm just gonna do both ways just to show you. Cross multiply. So once again, draw that box and divide it into 4 boxes. And we know what 100 always go in the bottom left box. 100 will always go into the bottom left box, right? The part and the percent represents how much money that he donated. So the subject line represents the value that was donated, right? So I'm going to put donated at the subject line, which is the first row, right? Now, the percentage of what he donated, right, compared to his overall savings was 16%. So I'm going to put a 16 right there, 16%, right? The actual amount of money that was donated was $800. So I'm going to put 800. Right? But just like 100, we don't have the whole, right? So we're going to put X, but we're going to solve for that. Okay? We're going to solve for that. All right? So now let's go ahead and solve. So I have 16 times X, which is 16X. Okay? Equals. And on the opposite side, guys, we have 100 times 800. 100 times 800. So let's go ahead and write that. 100 times 800. Okay? Once again, guys, just like the trick that I showed y'all over here, as we multiplying numbers that have consecutive zeros starting at the ones place, right? We can cross these consecutive zeros out and reattach them, right? So instead of us doing 100 times 800, we could do 1 times 8. 1 times 8 is 8. And I see that I have 4 zeros that I need to reattach. So 100 times 800 is actually 80,000. Okay? So I have 80,000 equals 16x. Okay? Once again, guys, the X, that's why I have it in blue, it represents the total, the whole. So we're about to find out what was the total amount of money he had in his savings before he started to donate. Okay? So in order to find that out, guys, we have to detach X from the value that's attached to it, which is 16. And the opposite of multiplying is dividing. So I'm going to divide both sides by 16. Okay? 16x divided by 16 is this x. Okay? And then on this side, guys, I don't have 80,000 has a 0 in the ones place, but 16 don't, so I can't do that trick. So I actually have to just divide on the side, okay? So I'm going to divide on the side. I have 80,000 divided by 16, right? Now, here's another little trick that I just teach my kids as I divide, right? I always use the shoe analogy, right? The number that you're dividing is your shoe size, right? Now, if you wear a size 16, you can't fit your foot in a size 8, right? Because it's too small. So it's nothing. I'm going to put an X. But if you wear a size 16, you can fit your foot in a size 80, right? So now we're going to find out how many times can 16 go into 80. I believe it's 5 times. Because 16 times 5 is 80, okay? So 16 goes into 85 times, and 16 times 5 is actually 80. So I gotta subtract 80 from 80, which is 0, And whenever you have a remainder of 0, but you have consecutive zeros remaining, you just move those zeros up. Okay, so these last 3 zeros is move up. Okay, so it shows that initially, before he donated, he had $5,000 in his account. Total savings. That was his total savings, guys, which is the whole. He had $5,000, right? And $800 is 16% of 5,000, right? So that is what we're going to have. All right. Now let me look at the problem to see if scale factoring will work always. Because sometimes, guys, it will work, but sometimes it will be a little difficult for the kids. That's why we'll always use cross multiplication. But when the numbers are easy to see and easy to work with, then you can do that. Okay. All right. So, and actually, guys, I'm actually going to do it. So real quick, just the last thing I want to show y'all, guys. If you did it by scale factoring, you will get the same answer. I just want to show it. So you did the scale factoring method. So once again, it's still the box method, divided into 4 boxes, and those same values will go where they go. So it doesn't act like we didn't solve it yet, right? Even though we have, just to see if we get the same answer. X, and once again, the subject line is how much money or the percentage of money that was donated, right? Okay, cool. Now, guys, when you do scale factoring, guys, you can either scale factor vertically up and down, depending on the position of X, or you can go horizontally from left to right or right to left, however you want to do it, right? So I'm looking at X, guys. X is in the bottom right box, right? So I'm looking at the scale factor. So let's look at the top row. I know that I can scale factor 16 to 80, right? I do know for a fact, guys, that 16 times 5, to 800, my bad. 16 times 5 is 80. So if 16 times 5 is 80, then it's safe to say that 16 times 50 is 800, right? So I know for a fact that I had to multiply 16 by 50 to get to 800, because 800 is 50 times bigger than 16, right? So that's what I had to do. So if I had to multiply 16 times 50 to get to 800, I would have to do the same thing going from 100 to X. So if I multiply 100 times 50, let's see if we get that same answer. So I have 100 and I have 50. Once again, if the numbers have consecutive zeros starting at the ones place, you can cross them out and reattach them. 1 times 5 is 5. Oh, let me put it in blue because I'm looking for the total. 1 times 5 is 5. And I have 3 zeros to reattach, which is 5,000. Okay? So, once again, guys, those are the 2 different ways that you can solve this problem to get the same answer. Okay? Thank y'all so much, guys, for tuning in. The next video, guys, I will go over example 3 and example 4 and 5 of how to solve percent applications. Thank you so much, guys, for tuning in, and I hope that all you students will have a great school year. Thank you.